Okay, well, I think we're gonna go ahead and get started now. So everyone should have a beer cracked open, I'm hoping. Again, my name is Joanna Powers. I'm one of the account executives here at Powerland. For those of you who don't know me, thank you very much for taking the time out of your afternoon to join us today. As the world shifts to more of remote workforces, Powerland and NVIDIA are joining together to provide a solution to deliver power and performance from home and anywhere. Powerland is one of NVIDIA's elite partners and trending towards Partner of the Year from what I hear. Our business is centered more around visualization competency, otherwise known as QUADRO. We have a dedicated media and entertainment team here in the West, and as we move towards more AI-based workloads, especially with the new release of cards in the gaming market, our team is very much focused on being able to enable remote workflows. Aside from having a very strong, competent bench and folks who come directly from the media and entertainment space here in Vancouver, we also have quite a large demo pool of cards that our customers often use to try out their applications and workflows. Today, there are two business units that you're probably familiar with at NVIDIA. The consumer gaming technology, which we won't really be talking too much about, and the data center side, otherwise known as QUADRO, which is what our conversation is going to be more focused on. We'd like to keep this as interactive as we can, and so any questions that come up throughout this presentation, we welcome you to submit the question through the chat tool on the Microsoft Teams meeting link here. We also are going to have a quiz at the end of this, and we have 9 times $100 gift cards to give out to the first correct response submitted through the chat. So we'll make sure to ask those questions. This will keep you guys all accountable to us, not just here for the beer and charcuterie, I hope, but we hope you guys get some great value out of this. We'll be going a little bit over some of the new releases that happened at GTC last week. And with that, I want to welcome a few of our presenters. We're going to have Morgan Davidson, who is the new Enterprise Account Manager for NVIDIA in Western Canada here, presenting first. We also have Griffin Lacey, a Senior Data Scientist at NVIDIA, and Michael Kaplan, the Director for Global Business Development for the Media and Entertainment Division. With that, I'm going to hand it over to Morgan. And again, I hope you guys keep this interactive and enjoy the next hour or so of our presentation.
Great. Good job. So I am sharing my presentation. And let me know if you can see it okay.
Yes, we can see it.
Okay, perfect. Thanks everyone. Good afternoon, good evening to a lot of my folks back east who have joined, who will be answering the Q&A while I present. My name is Morgan Davidson. I am on day 30 with NVIDIA, so I'm brand new. So if you want to take a drink every time I make a little bit of an error, feel free to do so, but I'll try and keep you sober. We broke this up into 3 portions. I'm going to talk a little bit to the vision and highlights of GTC. Griffin's going to talk about the latest in AI technology and DGX of NVIDIA, and then Michael Kaplan at the end is going to focus on what's new with media and entertainment. One thing I do have to do a shameless plug for Powerland. Far and away our #1 partner when you're talking about professional and data center products, a large lead over other partners. I've worked with most of the folks at Powerland, maybe too much, so definitely love the fact that they're pretty self-sufficient. They're an extension of the NVIDIA team, and also as customers, you're the ones who put them in that leadership position. So thank you for the continued support of NVIDIA, and I appreciate you taking the time out of your day, out of your end of your day for us to take a little bit of an update. First of all, just a little bit of housekeeping. This is our Canadian team. So we're focused on the professional and enterprise data center products. So think rack-mounted workstation and up. I have Manitoba West for those products. Adam covers Ontario. Eric, our boss in Montreal, has federal government, Eastern Canada and Compute Canada. I'm on day 30, so hopefully this goes well and I make it past probation. Claire is our partner business manager that works with Powerland. And the really important people are the 2 data scientists that work for us in Canada, who are there to bridge the gap between those very deep technical conversations with data scientists, machine learning engineers, application folks, and bridging that kind of gap to the technology. We'll speak in a little bit. So GTC was last week. All the sessions were recorded. There were 600 plus sessions, very deep. There was a lot covered. I am in no way going to cover everything that was announced during GTC. I'm only picking and choosing some of the highlights. But definitely, if you need a pass, let us know. We'll get you a pass. But I think they're up there for quite some time. And things like, Magnum IO for improving latency and throughput on storage, like super deep session, like very, very deep. So I'm not going to cover that today, but sessions like that are really, really interesting and have a lot of value. And then just kind of taking a step back to the vision of NVIDIA, 25 years of GPU computing, some new things. So the DPU, or data processing unit, or basically an offload acceleration engine at the network interface. That's new. So we'll talk a little bit about that. The important message from NVIDIA is that we're a full stack solution company, not just the physical infrastructure. So that's something that we need to reinforce, that it's the tools, the resources, and the people to make it possible to leverage GPU computing that's really important. And then just the scale of solutions that we're doing. And then of course, CUDA, the ease of leveraging GPU technologies is all based on the CUDA framework that NVIDIA created. Another way to kind of understand, what the focus is of NVIDIA. Obviously, our strength is in the graphics. It's very important to us. We'll touch on that. HPC is far and away the big kind of driver for NVIDIA. Our data center revenues surpassed our consumer revenues this year. And then AI, definitely the hot, important thing that is pervasive into almost everything. But a lot of people want to know where they can start, how to start. This bit of an eye chart here, I'm not going to go into all of this, but this kind of encapsulates this message of a full stack solution. It's not just the physical infrastructure that we're providing. Of course, it's the core of what we do, but it's the architectures that we design, the resources we provide. You can access NVIDIA technology in all the cloud providers. It's the libraries and software and help that we provide to organizations who want to leverage for existing applications that they have. DACA is similar to CUDA, but it's going to be a framework to easily deploy technologies onto network interface cards. But you can see from Jensen's, what I love about this quote is we'll leverage the open source tools that are and help develop them. But if there are no tools that exist or no solutions, I guess we'll create them. And you can see that in business applications and application frameworks. A lot of these have been created by NVIDIA, and we have thousands of people supporting these new technologies. So the big announcement obviously was the AMPERE for the business consumer. I mean, first and foremost, the Moore's law kind of dynamic where CPU sequential workloads is kind of tailored off. Yes, it's still increasing in performance, but it's more gradual. But GPU parallel processing is still doubling every couple of years. So by 2025, we believe there'll be 1,000 increase in performance on GPU workloads. So it's night and day, the CPU performance versus the GPU performance or parallel computing. And we'll touch on why that is, but that's kind of the main driving factor of going to AMPERE. Second generation cores on the RT, on the tensor cores. So for ray tracing, for machine learning, AI, that's going to mean a lot. Base 48 gigs of memory. I'll touch on that a little bit, but you can see that Moore's law going from 16 teraflops to 40 teraflops. We're not slowing down, we're accelerating that performance jump. I don't want to go because I have quite a bit to cover for highlights, but definitely the architecture of the tensor cores, where it's using a grid architecture where it can do multiple simultaneous calculations at the same time in a much greater number than a CPU is one of the key things. So you'll see within the AMPERE products, the A40 and the A2000, you're gonna see the cores don't increase as much, but this third generation of tensor core, still large jump in performance when you're talking about AI machine learning or complex analytics workloads. So here's the A6000. Michael Kaplan, who's going to be talking about media and entertainment, is going to go into a little bit more of the use case and how this is going to help, but definitely in that the RTX 6000 Quadro and the 8000, this is where the A6000 is going to fit in. You notice the Quadro name's been dropped, so I'm not entirely clear the messaging. Michael Kaplan will talk about that, but it's just the RTX 8000. Just keep in mind, although we're seeing a big jump in performance and that base memory and the largest frame buffer for a professional graphics card, availability is probably not going to be till end, maybe early next year. So, I wouldn't, delay anything because of this, because it's going to be a while before customers can get their hands on it. I think initial customers who are going to be testing out the A6000 with real workloads will probably be in the kind of November, December timeframe, and then general availability just after that. And here's the specs comparing the two generations. As you can see, the CUDA cores for raw performance, a big jump in the quantity there. The architecture is shrunk, but the actual chip itself is much larger. But as I said, the tensor cores, you're actually seeing a reduction there, but third generation. And then the RT core is not a big jump, but again, second generation. But a big jump in performance. And this 48 gigs of memory is going to be very important, especially when you're looking at virtual desktops on the sister card of this. That'll be important, or multiple screens, higher resolutions. Those frame buffers are going to be really important. Just a DisplayPort, higher power draw, and we're only supporting PCIe Gen 4 on this model. So the sister product with very similar specifications to go into the data center for server computing is the A40. Again, the big thing here that may change the VDI dynamic, I know one-to-one rack-mounted workstations are very popular today, and absolutely, that's a great option. But that kind of density and VDI that we might not have seen for creative, content artists and engineers, we might be able to show a very high density on the host by leveraging this card. So again, not going to see this card until end of year, early next year, but that may change the dynamics for certain when you're talking about VDI, and definitely when you're talking about rendering and performance computing in the data center. Just how this fits in, so the A1000 was launched earlier this year. Absolutely for AI, this is the fastest GPU possible. The A40 is definitely fitting in there for graphical workloads, rendering, VDI workloads. And then we still have the T4 for general purpose in the data center. That hasn't changed. And Griffin's going to talk a little bit more about the A100 and DGX later on, so I won't spend too much time. Here's a general basket of performance applications, and you can see the general performance between there. So, 2 to 3x, potentially even 6, 8x over the V100 technology, depending on what the use case is. And you can see a number of large data centers in the world are being based on the A100 more and more. And just as I was talking about where it fits in our platform, you have the A100 for, having that single kind of virtual GPU by tying 8 A100s in the DGX. That's absolutely something that's unique to the A100, but definitely, the A40 is no slouch. You're still going to be able to link cards together, but just not the 8-way. And edge computing, that's where you probably see more of the T4. Just want to touch on the Mellanox partnership that was announced earlier this year. So, in that, very large HPC environment, intelligent solutions at the network layer, you're starting to see us develop solutions together. But absolutely, Mellanox for InfiniBand, for low latency, very large HPC or very high performance, absolutely dominant in that space. RDMA is, absolutely superior technology for getting storage performance. But a lot of people don't know full product line on the Ethernet as well. But what I wanted to highlight was the partnership with NVIDIA and VMware, where it's Project Monterey that VMware is calling this new approach. And that's allowing offload of security, network profile, software-defined networking features, software-defined private, public clouds. They're going to offload that workload off the CPU and off the host from VMware onto an intelligent NIC. So we would call that the Blue Shield NIC from Mellanox that'll be doing that. But this will allow you for higher density. This will allow you to get below the hypervisor, and this will allow you to do, seamless hybrid, software-defined solutions. I don't spend a lot of time talking about it, but Checkpoint is one of the technologies that will be leveraging this. Mellanox makes fabulous interface cards. We're putting NVIDIA GPU AI technology into the NVIDIA DPU, as we're calling it, data processing unit. So that's very new, and that was kind of a big highlight. A lot of the VMware people are trying to get kind of a handle on this technology. But it's no different. I worked at VMware for 5 years. It's no different than when they were leveraging APIs to do direct calls into storage, into backup, into different technologies. So, VMware is very famous for creating ways to tie into their technology, but leaving it up to the partners to develop on that. So we're the first person to develop on Project Monterey. The last thing I wanted to touch on, second to last thing I wanted to touch on is the edge. So a lot of people really think of NVIDIA as a data center or workstation technology, but what you're finding is, especially with AI, it doesn't make a lot of sense to send raw data to a cloud or to your data center to be processed by an AI algorithm or model. The best use would be do that processing, say, on video security footage at the actual site, especially when you're talking about thousands of devices. So putting AI at the edge and then sending metadata makes a lot more sense when you're leveraging a public cloud or your centralized site than sending this raw data, raw video data, raw log data to a central site. So you're going to see more and more technologies from NVIDIA around managing devices. This picture up here is actual robot in the supercomputer SELENE, and that's using NVIDIA Jensen chip to run that robot. And then this is just further enhancing that. We've put frameworks for our OEM partners to build AI platforms at the edge. So, think of your large telcos to do AI at the network hub, or, security footage, or, in healthcare, say in cardiology or imaging, rather than sending raw data of all those imaging to a direct site. And then we announced it at NVIDIA GTC, managing all those devices and managing all that technology. So, when we're getting to the enterprise and you're talking about thousands upon thousands of robots and devices leveraging NVIDIA technology, we now need to manage all those devices. And so that was an announcement at GTC. If you're a Hadoop analytics company, night and day difference between GPU and CPU computing. So now we've announced this partnership and integration with Cloudera. So definitely, if you have a Hadoop project that you've been looking at doing CPU technologies with that, we now have this partnership and tools and platform for doing that through the GPU. Just want to touch on that NVIDIA, I wouldn't say off the shelf, but our regular products were deployed to create the #1 MLPerf score supercomputer in the world. So that was done in less than 4 weeks by 2 people, built this system, massive amount of cables. That was the #1 design constraint they found with designing this data center. It wasn't how do we build it, what technology, because it was all NVIDIA, Mellanox, all except for the storage was NVIDIA, but it was the cabling, just a massive amount of cable. I think they said, like, I'm not sure of an Olympic-sized swimming pool that could have fit all the cabling that went into this data center. But definitely in very large supercomputers, you're seeing more and more NVIDIA, Mellanox, and our technologies, just because it's easy to plug in these appliance blocks and do it like Lego rather than a custom designed data center, but quite quite an achievement. And lastly, I just want to touch on NVIDIA and ARM. That was a big announcement. It's still going to be a year and a half. It's going to be quite some time before the ownership of ARM is kind of finalized by NVIDIA. But we announced a lot of partnerships and joint technology with ARM. ARM is in almost every piece of NVIDIA technology. The Mellanox smart cards, Bluefield DPU uses ARM. Every one of our GPUs has ARM in it. But we can't speculate on what Jensen and the organization is going to do with this ARM. But I got to think if, you know, the CPU is a little bit of the bottleneck on the architecture, and we want to be a full stack company, you know, that probably is the direction we'll head. And with that, that's kind of the highlights. Again, I just want to encourage you to go to take a look at GTC. There's so many sessions there. But again, the goal for this session here is not really to sell you on any particular product. It's just to open the conversation that we want to, you know, have one-on-one sessions for any of these technologies that might make sense to your teams. So definitely feel free to ask questions and, you know, connect with your Powerland sales rep to set up a session if you like, if there's interest in any of these topics. Griffin, I think you're ready to go.
I am. Thank you, Morgan.
Yeah,
and thank you, Joanna, for the introductions. And thank you, Powerland, for having me today. I'm Griffin Lacey. I'm a senior data scientist at NVIDIA. So I spend a lot of time thinking about pushing data science forward. Sometimes that's algorithmically figuring out the right techniques and ideas that need to be implemented to improve, you know, accuracy of machine learning techniques. And then sometimes it's thinking about the cooperation between software and hardware and how to improve that efficiency. And so what I wanted to do with this presentation today, which will be very brief, is just give a bit of an overview of the state of data science on GPUs, at least as far as I see it. And hopefully this provides a bit of context for how we use the science and the ideas of what is state of the art in fields like machine learning and deep learning to actually inform how we design our hardware. So Morgan did a really nice job introducing this idea that you can use GPUs for more than just graphics, and that more and more over time people are using GPUs as a parallel computing platform for doing general math and linear algebra. So I thought I should start maybe looking at a slightly more focused view of the NVIDIA platform, as you already seen in Morgan's slides, and just talking through how it's possible at all that we can take some high-level application. Maybe you're trying to do you know, some financial trading prediction or something for healthcare, for classifying medical images, and how you're actually able to take a you know, general machine learning practitioner or data scientist and have their work be enabled and accelerated on GPUs. And so if you consider NVIDIA a platform company and you start looking at this graphic at the bottom level, you'll notice that we have a wide array of different implementations of our GPU architectures. So we have everything from Tesla, which is our enterprise class GPUs, to virtualized GPUs, to these supercomputers that we manufacture in our OEM OEM partners manufacture, and we're also available in all the major cloud service providers. So regardless of where you're consuming or using GPUs today, all of these different iterations of our technology are all going to use the CUDA platform. So CUDA, which is our Compute Unified Device Architecture, is basically the software layer that allows a high-level application to talk to the GPU. And so regardless of where you are running your code, you're going to write the same high-level instructions, which are going to be compiled down to something that the GPU can understand. And the fact that this is consistent across all of these different types of GPUs is a really powerful idea. And so to take one step up from that, we compose these, what we would call our CUDA-X or CUDA accelerated libraries, which are collections of these CUDA accelerated codes that are specifically designed for particular collections of functions and routines. So for example, if you are concerned with deep learning, typically that's going to mean that you're concerned with things like two-dimensional discrete convolutions or recurrent cells. And you're going to take use of, in the common high-level framework today, something called cuDNN, which is our deep neural network library. And so this is a collection of these operations that accelerate deep neural network operations. So similarly, we have libraries like cuBLAST for linear algebra, or Nickel for collective communications. Over on the right, we have QFFT for fast Fourier transforms. Basically, we've composed all of these really powerful, efficient, and fast primitives for accelerating these high-level applications. And in practice, actually, as a practitioner, you don't have to think or even be fully aware of what all of these things do, because if you look further up the platform, you'll notice that if you're just say a deep learning practitioner and you're using something like PyTorch and TensorFlow, those libraries are going to make use of our CUDA accelerated libraries where possible, and they're going to do it all sort of behind the scenes and automatically. And this is a similar story for in high performance computing. So in codes that are important for, just say, like physics or computational chemistry. And then similarly on the machine learning side of things, if you're doing just more scientific Python and doing just say ETL or visualization, we have a collection of libraries that are going to accelerate those workloads as well. So really the takeaway from an overview of our platform like this is that we've done a lot of work to make sure that whatever application that you're running and whatever use case you care about, chances are that there's going to be GPU support for what you're doing. And I think it's important to just take a bit of time as a scientist and as a researcher to just be aware of all of the tools like this that can help accelerate your research and your experiments. And so for those that are familiar with the progression of deep learning, for example, over the last 10 or so years, really deep learning and GPUs have grown up together. I mean, deep learning as an idea is not very old, maybe just over a decade old at this time. And really in the early days, really since Alex Krzyzewski at the University of Toronto developing CUDA-ConvNet, doing these large-scale deep learning models and training ideas has really been the software tools that enable that have really grown up with NVIDIA GPUs in mind. So really, in terms of what people are doing today, it's overwhelmingly the case that if you're a deep learning scientist, you're going to be using either something like Google's TensorFlow or Facebook's PyTorch deep learning framework. And these, if you can go and look for yourself at the documentation online, you'll notice that the semantics of CUDA, and so really the way in which you can use an NVIDIA GPU is built, is by construction designed into the frameworks themselves. And so really as a researcher, you don't have to care too much about what a GPU does or all of the nuances that our latest architectures have. You just have to basically describe the experiment that you're trying to run in TensorFlow or PyTorch language, and the frameworks themselves will do all of the hard work behind the scenes of making that run on GPUs. And so similarly, there's this other effort that's more broadly focused on the machine learning space, which is a bit more general than deep learning, which is that we've been involved in this effort. We call the umbrella term for it is RAPIDS, but it's basically this effort to create this ubiquity similar to what has been experienced in the deep learning world, more generally in the machine learning world, which is to enable all of the tools that data scientists care about on GPUs. And so two good examples of this would be if anyone is familiar on the call with Pandas, which is a Python library for data frame manipulation, or scikit-learn, which is a Python library for machine learning. Basically, we have now a GPU accelerated version of Pandas we call QDF, and a GPU accelerated version of scikit-learn we call QML. And so really the takeaway from these slides is not to memorize these specific libraries or anything like that, but really it's to be aware that really whatever you're doing in the space of data science today, chances are you're going to be enabled by GPUs. And so as you can tell, right, with all of this ubiquity of NVIDIA GPUs in the data science space, some of these tools can be quite sophisticated, and it's sometimes it's not a trivial matter that your standard or your average data scientist really knows how to build these libraries, which can be quite sophisticated, from source, and they can make sure that they're getting the most out of their GPUs that they can. And so in order to help researchers along in this way, we actually have something called NGC, the NVIDIA GPU Cloud, which really, when it started, was a repository of these containers where we'll take a code like TensorFlow or PyTorch, and we'll optimize it to a very large extent with a lot of sophisticated engineering effort to make sure that we deliver an environment, a software environment that is going to run TensorFlow or PyTorch or similar or Rapids really as fast as possible on NVIDIA GPUs. And so if you go on NGC, you can get and pull down one of these free containers today, and you can have a version of TensorFlow or PyTorch or similar that really runs as fast as possible, given all of the challenges of doing that today. And over time, NGC has actually evolved into something even more sophisticated. So now we have all of these really useful train models that we've put up on there. So if you're doing something like natural language processing or computer vision, we've trained these really sophisticated models and actually just put them on NGC for you to download and maybe fine tune on the data set that you care about. We have Helm charts for Kubernetes applications. We have a whole suite of AI toolkits for a number of different verticals like healthcare and smart cities, conversational AI, robotics, and more. And so really, I think the takeaway from this is just to understand that as a practitioner, it's good to be aware of things like NGC, such that you are making sure that your software environment is going to take the best advantage of the GPU that is possible today. And really, there's a lot of help for you out there if you know where to look for it. And so one really important thing to notice about what is possible with something like using something like NGC containers is that we put a lot of effort, as I mentioned, into optimizing them and making them go as fast as possible. And so you'll notice that from 2016 to 2017, there was a jump from Pascal to Volta architecture. In 2019 to 2020, we now have this jump from Volta to Ampere. And of course, when you move across a generation of hardware architecture, you get all of these great benefits of just moving to things like a smaller feature size or process technology, and then all of these innovations that come along with that. But one thing you'll notice in this slide, for example, is from 2017 to 2019, just on the same architecture on Volta, we were actually able to squeeze, from comparing to the P100 architecture, 2x to 3x to 4x more performance just out of the software itself. And if you're curious about the technical details here, this was a basket of top apps, basically a reference benchmark suite of apps that are really important in the domains that we care about. So things like AI and machine learning and physics and computational chemistry. And so the real takeaway here that I think is important is that yes, it's getting a new GPU is great, and with it comes all of this really nice speed up for the code that you're running. But also, there's a lot of software optimizations to be had over time, and consuming something like an NGC container instead of maybe building these libraries yourself is a great way to make sure that year over year your code is running faster. And so to jump right into the A100 architecture, which Morgan introduced before, there's a lot of technical specs here that I won't go over, but I just wanted to maybe tease this idea that with our newest GPU architecture, that there's a lot of really cool innovations that we've introduced here that are going to help your data scientist, your machine learning practitioner, your deep learning practitioner go a lot faster. And so there's two features in particular I wanted to talk about briefly, and these are quite sophisticated ideas, so obviously this is not going to be an exhaustive overview of that. But there's this one idea, which is tensor cores, which is that when we know that people are using our GPUs to run things like neural networks for deep learning, we understand that there's common operations that people implement in these neural networks, so things like dense matrix multiplications. And so we've introduced these resources on our GPUs called tensor cores, which are directed specifically at accelerating these matrix multiplications, which are so important to fields like deep learning. And actually, we do so in precisions that are not your standard FP32 precision, but actually now it's this precision we call TensorFloat 32, which is a hybrid between 16-bit floating point and 32-bit floating point. And so really the takeaway here is that what we're able to do now is actually with no code change, your TensorFlow or your PyTorch code is actually going to make intelligent use of these Tensor Core resources on the A100 where it can. And by using fewer bits to actually run those operations and using these really fast dedicated resources, it actually ends up being a very significant speed up over what is possible just with your more naive approach using FP32. And I'll talk about the speed up in a moment. But the other feature I did want to talk about, which is also important to be aware of, is this thing called MIG, or multi-instance GPU. And it's this really, really cool implementation on the AMPERE architecture and on A100 specifically, which allows you to actually do a physical partitioning of your GPU into several smaller GPUs that have the important characteristics such as guaranteed quality of service and their own set of resources like streaming multiprocessors. And so this is really cool because you can almost think of it as a tool for utilization where sometimes you're using a GPU and maybe you're not fully utilizing all the resources, and maybe there's somebody else in your machine that could be taking better advantage of the leftover resources. Well, now with MIG, you can sort of configure it to be the right size GPU for your application, and you minimize waste across your system. And so, well, what does this all mean for acceleration? Well, if you look at, for example, training, which is the process of taking a machine learning model and feeding it all of these example data, such as images and computer vision, and updating the model parameters to better maybe make some prediction or classification. So with comparing AMPERE A100 versus our previous architecture V100, using things like FP16 or TF32 out of the box, you're getting roughly 6x speed up versus what was possible on our previous generation, which, for anyone familiar with how generational leaps go in speed up, that's very, very significant. 6x is really big. And as well with inference, which is the process of taking this trained model that you've developed and actually deploying it maybe in a production environment. Maybe you want this to be customer facing. You want somebody on their phone to be uploading pictures and it classifying the images in real time. Actually, with MIG, we now have up to 7x throughput improvement over what was possible on V100 because of this more sophisticated usage of the resources on the card. So these are two really important hardware features of our latest generation of GPUs that cooperate really well with the software to deliver what is very substantial speedups. And so I'm going to go quickly because we're sort of running out of time here. But basically, over time, AI is obviously scaling up. I think anyone even passively watching the news is familiar with this. Basically from 2013 or 2012 to now, we're getting 3,000x more complexity in the models that people are training to be state of the art. And so really, this means that we have to keep up with that trend by making sure that the amount of compute available and the ability to train these models fast is going to stay reasonable, so that you don't have to wait like a year to get a single result of training your model. Even though the complexity is growing 3,000 times, and that trend seems to continue, you have to be able to train your models in a reasonable time. And so the way that we approach this, you can think of it through the hierarchy of scales. So if you look at even a single GPU like our A100, it's composed of a bunch of these parallel processing units. So the hierarchy goes from having these streaming multiprocessors, these SMs that compose this GPU, and now we have these multi-GPU systems that are composed of many of our multi-SM GPUs. And now we define these data center designs, which have multiple numbers of these systems connected together. And so really, the end goal here is to comprise a system and design a system that's going to use this idea of hierarchy to efficiently enable somebody to take a simple experiment or a simple idea and scale it up to be something very, very large. And so in terms of a single server design, we've introduced recently our DGX A100, which is a server that has 8 of our A100 GPUs on it, and all of these really fancy technologies such as NVLink for high bandwidth interconnect between the GPUs, and then all of these Mellanox ConnectX 6 card for high throughput performance between nodes. And so really what this amounts to is that we've introduced something called DGX Pod, which is our reference architecture for actually building full data center scale systems comprised of these DGX systems. And so we've got a lot of these proven architectures that we've developed with our leading storage partners. And if that's something that is interesting to you, if this is something that you're looking to do in the future, it would be worthwhile reaching out and having a pod discussion with us. Because as you saw with Morgan introducing SELENE, I mean, we have a lot of experience with building data centers specifically for data science and AI and doing it with DGX. And so with that, I will turn it over to Michael.
All right, let me get my slides up. Can everybody see this?
Yep, I can see it.
Perfect. So let me also start by saying thank you, Powerland. This is awesome. And because I work for NVIDIA, I don't even know that I could say, Griffin and Morgan, that was awesome. Great presentations. Morgan, you've only been here 30 days. I have been here 3,663 days. So I'm super nervous because you guys really set the bar. So for everybody listening, trust me, the more you drink, the smarter I sound. So let me get into this right now. All right, so I was told from Tony that not everybody's media entertainment, and although I do really focus on M&E quite a bit, I just wanted to kind of go big picture about what is happening with visualization across all markets, whether it is automotive, media and entertainment, which I love, healthcare, AEC, everything is starting to go on now where it's so important to be as accurate and as photoreal as possible, and just the level of complexity continues to increase, and the need for acceleration is across the board in every industry. I'll also say that obviously the pandemic is what an awful situation, but in a way I think that it might have kickstarted some companies into looking at virtualization and what is the right remoting solution. So we take a look at you know, it could be mobile solutions, you could be doing remoting from a PC or what have you, and then you can potentially start to get into scalable virtualization with partners like VMware and Citrix. And even today, there's capabilities in the cloud. So many of our large CSPs and cloud service provider partners are actually turning on the capability of doing virtualization. So again, I think now more than ever, and even in media entertainment, it's such a necessity, and I know the technology's there. So that's another reason to talk with us and see what we might be able to do to help you out. As I kind of slip into media and entertainment now specifically, let me advance the slide. All right, so for M&E specifically, right, I think now that the amount of content, and you can take a look at news at how much, you know, the Netflix of the world are spending on content. Yes, some of it is talent, but it's amazing how much money is being spent today. And when you talk about the quality and complexity, we have so much to watch, right? And I think our eyes are getting mature enough to know when you're looking at good content and you're looking at really, really bad content. And you know, the audience really pays attention to that. Globalization, because we're kind of working everywhere now, and we have studios that could be in Vancouver with your peers that could be in the UK or New York or all over the world. It's so important to be able to be collaborating in a global scale. And that actually leads into content security, right? You don't want things to be stolen. You might be having folks coming in that could be freelancers, and you want to have access to resources, but you don't want them to really get access to content. So more and more with content security and all these 4 boxes, that's what we kind of see as a big area of concern and areas to look forward to within media and entertainment. Right, there's a lot of stuff going on now, and it's hard to say what's the one thing that's kind of stepping up. You know, 8K, super sad about Olympics not really happening right now, because I think in Japan that'd have been the first place that we really start to see 8K, but you know, we're moving into HDR and high frame rate, and that's super exciting. We take a look at remote work and collaboration. I'm going to spend some time a little bit later on something that's called Omniverse, which was introduced a while ago, but reintroduced and really ready for beta right now. And we just talked about it at GTC last week. There's a lot of things going on with 5G and technology that we have called Cloud XR that could be doing streaming AR, VR, and XR. And I'll do a little bit of a segment on virtual production, and I will actually close off with artificial intelligence within this industry, both from a kind of build your own, and Griffin kind of talked about the framework that you kind of need to start doing your own, but then I'll also drop in some of our third-party partners that are actually doing it if you don't really have the chops to potentially write your own software. Right, again, let me talk about visual computing as a platform, and I think when you speak to folks at NVIDIA, we're going to kind of go away from sort of a card-only story, and we're going to get more into understanding what workloads are and really what, from a customer standpoint, is the right thing going to do. So that could be software collaboration. It could be doing data science, right? You might have to be figuring out some analytics, or it might be doing some artificial intelligence work, and you could start easy before you scale to like a DGX A100. So it really is an expansion of where visual computing can happen as a platform, and that's going to be an interesting point and an area to focus on as we start to go forward. Now, you know, this is not a spoiler alert, the two green circles that are on the slide right now, because you've actually you've heard a little bit from Morgan about what was recently introduced. So it's not a sneak, but we actually did introduce AMPERE technology from a visualization standpoint, and every workload that you see here, whether it's rendering, virtual workstation, simulation, everything, it's really ready now for AMPERE. As was stated before, it's going to be a while before our distribution and OEM partners have those ready in workstations and servers, so be a little bit patient. The RTX cards that are out today are absolutely phenomenal, and it's work that can be done today. So when you're going forward, whether you still choose to be in a workstation or you're definitely in the mindset it's time to go in the data center, there are going to be solutions coming out from NVIDIA that are there today, but advancing into the new technology and the new architecture called AMPERE that you guys will have the ability to take advantage of. So because folks spoke about it, again, I'm just going to go quickly through this. Again, A6000, probably more for a workstation. That's not to say that some server vendors won't actually, you know, authorize and qualify an active card inside of a server chassis, but we're really thinking that RTX A6000 probably going to be in workstations. And then when you're looking for a passive card, which a lot of vendors and OEMs do want, that's what the difference is going to be. They're pretty much identical cards. There is a display port difference. The A40 has 3, the A6000 has 4, but other than that, everything is really on par from one to the other. So as was talked about, right, when Turing came out and it was introduced, Turing was the last architecture that the RTX 6000 and 8000 were based upon. When Turing came out, we probably spent 10 years on that architecture, right? And we talked about programmable shaders. How could we up that? We introduced something called an RT core that is silicon specifically meant to accelerate ray tracing. And I'm going to go into a little bit of detail when I talk rendering next about the goodness of ray tracing. We also introduced, actually carried forward from a previous generation, something called a tensor core. So tensor core, as was discussed, perfect for edge and inference utilization. In the media entertainment world, that could be applicable in a task like denoising. So as you're trying to render out an image, whether you're doing interactive or final frame, more so probably for interactive because you're taking a look at it, the denoising knows the pixel colors that the scene is supposed to be. So you don't really have to wait for the render to go full force, because the AI will start to inject what it knows the color should be in each pixel, and denoising is going to really accelerate what a render is going to look like. So now let me just kind of quickly get into GPU rendering. It's been a big area for NVIDIA, and it's taken us a long time to kind of be like legitimate and really in play. as I said, I've been here for 10 years, and like every time I spoke about GPU rendering for 10 years in a row, I would say every year, this is the year of GPU rendering. And every year I was lying. But I really feel good that we're at a point now, and there are so many applications that are out there and taking advantage of it, that it's time now. And if you haven't had a chance to take a look at applications from Autodesk with Arnold or Redshift or Chaos V-Ray, now's the time, because the performance is mind-blowing, and you really need to start paying attention to it. It's a super important area, and it means a lot to us as an organization, and we put a lot of hard work into it. So let's go back a little bit, right? This has been going on for, gosh, probably before like 1978. This is forever. We had a gentleman, actually an industry luminary, Turner Whitted, who actually was part of NVIDIA research for quite some time. Back in '78, he started saying something about the need for massively parallel technology in order to do ray tracing, right? And for those that did physics, you understand what ray tracing is and things like that. It's been around for a while, but in M&E and media entertainment, the things that started to accelerate ray tracing are things like global illumination. We see it in computer graphics for quite some time. It's done in a few different ways. It could be rasterization, which is typically done in games, and ray tracing, which has been done in Hollywood, but it's usually done on, you know, huge giant servers that could do a frame for days and weeks. But now massively parallel, which is the nature of what a GPU is, starts to bring this more to a real-time scenario, and that is super exciting. What was said so long ago is now becoming a reality today. So ray tracing, you guys might all be experts at it, but the easy way to think about it is like if you look around right now and you're taking a look at objects in the room, and I'm kind of looking at like TV displays in my office and lights, and you start to see, you know, where are the beams going from the light source to your eye and back. That's kind of what ray tracing is. Rasterization, on the other hand, calculates like triangle brightness, and it kind of just goes from one point of the eye to the source, right? And it's a little bit easier. They have something that's called like baking, where it's pre-done, and if the light moves in the scene, the shadows aren't going to keep up, because that's not what it is. But when you take a look at ray tracing, with the way it's everything's bouncing off in real time and going everywhere, it gets that realistic view in such a fast way. That's what more and more folks are kind of getting into. When we take a look at the market itself, you know, what are people worrying about, right? It's render times. As I said, some of the big blockbuster movies, it could take sometimes 2 weeks, if not longer, for a single frame. And you guys know that in film, it's 24 frames a second. Imagine that a single frame could be 2 weeks. That's kind of crazy. Now, again, big houses have huge thousands of cores for CPU, so it's really not always like that, but it takes a long time. So that's the first thing we look at when we talk about the challenges. The second thing is the expectation. And like I said, you know, it's not necessarily about me anymore, hard to believe, but it's like my kids who are actually adults, and everything's on their phone and tablets, and they have about a 2-minute attention span. And if something doesn't look good and the visuals aren't awesome, they're on to something else. So from a competitive standpoint, all our customers absolutely need to be the ones that put the best content out. And then we go into cost. What does that mean, right? With GPUs and getting into GPU accelerated rendering, we've really brought that cost down almost like 1/10 of the cost. I did some math with a customer, and they might even be listening now, Cinesight, right, who did some testing on RTX early on for a Netflix show. Now, all they did, because the software wasn't ready when they did the production, they actually took some of our technology and reran what they had already done. If they went GPUs, they saved so much time. They could have shrunk their footprint so much that just with the cost of power, they would have paid for the 4-way GPU servers. So when I say it's a real cost saving, it surely is, and it's something that we could be having conversations on today. Just a quick highlight about a customer of ours, Unit Media in the UK, and I won't go too much, but this is from a software partner called Redshift, a pretty up-and-coming render partner. And this was an example of a CPU-based system that took over an hour on some scenes. And when they went into a GPU system, they actually brought it down to under a minute. So the numbers are real, and you know, there's a ton of applications out there now, whether it's for media entertainment, AEC, manufacturing, and all of them are taking advantage of RTX acceleration. Another quick one, I love this one, a good customer of ours, Digital Domain, and again, maybe some folks are listening in now. This is something where they actually took a look at RTX technology for rendering, but they're also using this for AI. So the things that they're doing for digital humans, and if you don't know Doug Roble, this is Digital Doug, and you can actually search that Doug Roble Digital Domain, search it on YouTube, and you'll see it's uncanny how real the digital human is to him. And he goes in depth about how they did it, but they're taking a look at, you know, the NVIDIA technology. They're using RT cores. They're also using tensor cores on these GPUs because inference matters from the AI tasks. So there's a great example, and definitely take a look at it on YouTube because it's phenomenal to watch. As I go on, as I said, today there is over 50 applications that are taking advantage of RTX acceleration. When we first started 2 years ago, when we introduced this at a SIGGRAPH, I think there was not even one. So we've come a long way. And you see some of these logos, not everything is media entertainment, because any entity or any industry that's visually heavy are now having software ISVs take advantage of what RTX brings to them, and it's super exciting. So let me take a quick jump. I'm not going to spend too much time in virtual production, but if you're reading any trade rags or you just get any news feeds, this is a big to-do, right? I don't know when people are going to get 30 or more folks on a set in the near future, and I know that Hollywood is pushing out all these different, you know, mandates and how do you do something that's sort of COVID safe and things like that. But what we do know is virtual production, and that could be used from a scouting standpoint. You could be doing filming on it. And when you go beyond just a simple green screen or a single green screen and you go into the big expensive like LED walls, that's where it starts to make sense. Unreal, not the only real-time engine out there. Unity is another big partner of ours, but Unreal, I think, is a little in front when it comes to virtual production. But there are things within NVIDIA like sync technology and the ability to scale beyond a single GPU and get into multi-GPU rigs with 4 or 8 RTX cards. That's something that if you're into this type of thing and you're starting to do work here, please let us know how we can help. One of our great customer partners, Pixamundo, just pushed out some press just last week, and we're partnering with them, and we'd love to work with as many folks as we can to make this a reality for everybody. As I referenced before, there's a lot of things that you're going to need. And look, I have QUADRO on these slides, so I guess these slides are a little outdated now because you're right, we are kind of going away from the name QUADRO. But all these things like warp and blend, bezel correction, when you're trying to tie different LED walls together and you want a smooth transition, there are things within our enterprise class of graphics cards that come into play, and we definitely want to talk. Now I'm going to get into some of the fun stuff. This is something that's called Omniverse, and I'm not sure. About a year ago, when it was introduced for AEC at one of our events, that was like the first time the world saw it. Now we really kind of came out and we did something specifically for not M&E, but it's M&E centric. But it's interesting with Omniverse, and I'll get into a slide here in time. A lot of our industries are going to start to take advantage of this. Is fantastic technology. So let's take a quick look at really what is this, right? So in a world today when you've got a lot of different things taking place. You know, it's sort of one-to-one. So you've got folks that are kind of using Unreal. You've got another person that's doing things with Revit or Substance, and maybe Unity and Maya are all involved. But it's very one-to-one, and I don't really know what the other person's doing, and I'm only worried about my application. That's kind of how it is today, right? And it keeps going and going. Well, I need to take a look at this effect, and what are we doing for the color of this, you know, the carpet or the wall, and what the light bounce is going to be. And it gets super, super confusing with that. So now we introduce something called Omniverse, and Omniverse is really the collaboration engine that gets everybody involved, right? And really, it's all done through something called USD, which is Universal Scene Description, something that Pixar brought to market. It's sort of open, and we're doing our best to make it better and keep it as open as possible. But the trick is, if you can talk to USD, you can be part of Omniverse. Some applications, a lot of M&E applications already do this, but some in other industries don't. So we're doing everything we can to work with folks and software partners that may not necessarily be native to USD to figure out how do we get them into this Omniverse world of collaboration. And that's coming along quite nicely. You'll see over time the number of software partners that get introduced as part of the Omniverse platform. And as I said, like it's, you know, I want to say, oh, we're only focused on media entertainment. That would be awesome, but that's not true, right? So when we simulate reality with Omniverse, we're actually doing it for robotics, and we're using it for autonomous vehicles. It's a mouthful. And then obviously in media entertainment. So think about you're an artist in Vancouver and you're actually doing some work with your peers in New York. Today, you might have to send like an MOV file and take a look at what it looks like. With Omniverse, as you're looking at this scene and you're trying to make a change within the scene, everybody's kind of communicating in real time. So somebody could say, I need that wall extended, or the color of this rug needs to be this, and somebody's painting, somebody's doing modeling, somebody's doing some rendering, and we all see it update in real time within this world of Omniverse. Okay, so it's super exciting. As I said, beta was just introduced at GTC, so if it's of interest to you, definitely get signed up because I think it's something you're going to want to try to incorporate real time. So again, the partners that we're working on, we bring in the major players in all the spaces, and those logos kind of represent real-time engines as well as traditional M&E applications and others. We bring it into the Omniverse world, and we can kind of add physics from NVIDIA, which would be like a table breaks or window breaks, and it breaks like it really would in the real world. We have material definition language with what we're doing with materials, and we all kind of bring it together with USD. So it's super interesting. We could go really in depth on a deep dive, and if you're somewhat interested, I would suggest that's something we set up, because when you actually see it and you get presented it from the application standpoint, you're going to be blown away. Come to think of the different modules, if you can get your hands on it, this is going to mean something different for an end user, and it's going to mean something different for a software developer. Some folks might write to one of these modules, and the end user will just take advantage of the hard work that's been done, and you'll figure out in time what's the one that's going to matter to me. Okay, Omniverse is something that could actually be done one-to-one. So if it's a standalone, you know, workstation and an artist that's just trying to see different applications tied together on one screen. So imagine you've got like a Maya window, you've got a Substance window, and within the Omniverse window, you can see all the changes happening to the model that you've done in different applications. So that's a benefit. And then when you keep going on, if it's not just one person, as I said before, you could have folks all over the world. And if you see the image on the right, you're going to change the horse. You're going to change the structure of a carpet or a blanket thrown over the couch, and people are going to change that in real time. Part of Omniverse that's in beta now is the rendering technology that NVIDIA brought to market. We are partnered big time with the real-time engines, like I said, Epic and Unity. But we ourselves put together some software that those companies plug into that does real-time path tracing and ray tracing. Another Google thing, after you take a look at Digital Doug, you could take a look at NVIDIA Marbles that we showed at GTC, and this was all real-time done within Omniverse. So super exciting to take a look at. So please pay attention to that when you have a chance. Now let me talk a little bit about artificial intelligence within this space. I already talked about denoising. That could be one way to take a look at it, but I'm going to go into a few other areas. Morgan, I think, showed this slide before. This is kind of a different way to talk about graphics and HPC and AI coming together. As you guys know, or may not, when you start to do training, we're going to say it's a DGX A100, which beyond any doubt is the best system that NVIDIA brings to market. Right? You can start to scale down from that, but the best of the best is the DGX A100. Could you start small on a server with a few cards? Yes. But just understand, when you start to take a look at high performance computing and computational workloads, we're going to make recommendations for you on what we think the right platform is. We've been working with a lot of customers, and as I said, you might want to write your own software, and you might want to take advantage of all the frameworks that we're accelerating and pay attention to NGC and do it yourself. And this is an example of what we've actually done with our partner Disney. So Disney actually is doing something called sentiment analysis, right? So what they do if they're kind of previewing a show and they're taking a look at the audience, they're going to look at, you know, are the children happy or scared? What are the parents thinking? And they could potentially make a change in what that content is. And this is all based on AI, something that was done and trained on NVIDIA technology. This is another interesting one. I have not cut the cord. I'm a Xfinity Comcast customer, and my remote control that I talk to every night is actually trained from a natural language understanding standpoint on DGX technology. So I could ask for specific actors and actresses, genres of films, and it's going to kind of pick it up, and that's going to start to actually do recommendations based on my viewing habits. And they're doing frameworks like Keras and TensorFlow and PyTorch, but this is an example of somebody more in the broadcast industry, so, and some of you might be there as well, and not just visual effects, but this is another great example of a customer that was capable of doing some of this work themselves and took advantage of what NVIDIA technology has to offer. For those that don't necessarily want to do it yourself, we have partners like Blackmagic with DaVinci Resolve. It's a GPU monster. It will take as much as you want. And in some of the recent changes they've made, they have something called the DaVinci Neural Engine. And this is AI taking advantage of the processors and the tensor cores on the GPU to really start to do like retiming, and it'll start to do upscaling on footage. And all of this is done with artificial intelligence super fast when you have the RTX technology in there with the tensor cores. So if you haven't turned this on, definitely turn this on. Have to have the right technology in-house, but you're going to love this stuff. And then also I'll talk about Autodesk Flame. It's the same type of thing. So they've got like Z-depth map generators where they're taking advantage of the tensor core on the RTX technology. They're actually able to start to do effects based on distance from the camera, and they're starting to do like human face map generation, and all of this technology is being implemented with artificial intelligence. So another great partner that's traditional in media entertainment, but they realize that they have to go to the next level, and AI is the way that they're going to get there. So I'm done right now. So I thank Powerland in the beginning, but I'm going to thank all of you folks as well. I know that right now, I know you're in Canada, but you could have chosen to watch Joe Biden or Donald Trump do town halls tonight, but you chose to listen to NVIDIA. So thank you for that.
I really hope that you had, there was a lot of product expertise and knowledge that was gained for you over the last hour and a half, and that you enjoyed this session. I hope more so that you're able to take advantage of some of the newer GPUs that have been launched. And of course, Powerland and NVIDIA, Morgan and our friends, we're here and happy to help you with that. And with that, I want to thank you all for joining, and I hope you have a wonderful evening. Signing off.